listen, guys, I am sorry. And it's not because I don't think I would ever make a mistake. That isn't, for sure I make mistakes. So please don't think that's what I would ever think. I spent a lot of time on the problem because I do the notes ahead of time. I do all of your homework problems ahead of time, like 99% of the time, 99% of the problems. So I work pretty much as hard as you guys do. But sometimes, and she has a whole mistake file that she sends us of mistakes that she has. Sometimes I don't have a chance to look at it, but I'll catch something that I'll catch or whatever. Whatever. She was right, I was wrong. So I want to explain what I did wrong so that you guys can see, right? Sounds like some of you already knew, so I apologize to any of you that saw it and I denied you. All right, so here's the thing. We saw that we had a negative amplitude, or amplitude of 1 with a flip, and period of 4 pi, and we were only graphing on we were graphing from negative 2 pi to 2 pi. And I started left to right, and I graphed it. Where we should always start our graph on the x-axis. So, in other words, I should have started my down, middle, up, middle, down, starting at the origin. So, down, middle, up, and it keeps going middle, down, okay? The whole, whatever it is. But if I'm not going to keep going in that direction, I would go in this direction. So, I was right in saying, like, my endpoints should match, because that's true on a cosine graph. They should both be up or both be down. 2 x-intercepts and then a max or a min, right? But I just did it graphing from left to right instead of graphing backwards. And then Gavin Blaska, if you know him, he gently, they were so polite, such sweet, they sit in the same seat. That's so weird. 7th period, when I was explaining my mistake to 7th period, when I went over to him, he goes, I think that your issue, Miss Morse, is that you don't like to graph backwards. And that's where your mistake was. It was just so cute that he pinpointed what I was, whatever. So anyway, we always start our pattern at the origin. That's what we have to remember. The pattern of up, middle, down, middle, up, or the flip of that, or middle, up, middle, down, middle, or the flip of that at the origin. And then we go to the right or we go to the left and finish the graph however it tells us to do. Okay? So does that make sense, guys? I apologize. Don't hold it against me. I like to let you guys know I'm human too, right? I'm not just this perfect math person up here doing all perfect graphs and everything. Sarcasm. Second thing I need to tell you, some of you don't go on Canvas, Ronnie. Right? Some of you don't go on Canvas. I put this on Canvas. So I'm going to do a real quick explanation of how the calculator checkout stitch is going to go. And then if you missed anything or you still have questions, I put an announcement on Canvas along with this. So calculators, we're about ready. We're ready to start the process. So if you are interested in checking out a calculator, the first thing you're going to do is QR code it up, whether you use the one on Canvas or I taped one to next to your phones, okay? So there's a QR code. That's where you will start, or your parent starts. And it's a very short little QR code, questionnaire, blah, blah, blah. Student number, first name, last name, yes, I agree, digital signature, and the agreement is attached to that. So you can click on it and open it and see what your requirements are, which is don't break it, don't lose it, or you pay for it. And then once you do that, I'll have some checkout sheets in class. So I'm going to set them up on the table over there, and I'll have all 5 periods. You'll write your name on yours. It's very self-explanatory, kind of like the old school textbook checkout sheets that you used to have to do before they were barcoded. And then once I have the list somewhat compiled, we'll figure out, do I have a whole bunch of you guys where we have to make a field trip down to the media center together, or do I just have 3 or 4 of you in a class period and I can say, okay, you 4 run to the media center and get it? Because you have to get them from the media center, from Miss Amio Prizo. She's barcoding them just like textbooks, and she will check it out to you like that. So they can track it. If you're graduating, you don't give it back. You don't get your diploma to get the calculator back, things like that, okay? So you will be getting the nice one like Sabine has, the one that charges. It has color. It's thinner. Does all the same exact things. You don't have to learn any buttons or anything, but they're just nicer. It's free. Doesn't cost you anything. You can leave it at home and still use the class set if you're worried about losing it. You don't have to check it out if you don't want to. It's completely optional. So let me just tell you, if you check one out, it's yours till I figure out how I'm going to collect them after the AP exam, because graduation is 3 days later or something like that. You'll hold on to it until you don't need it anymore, and then you will bring it also to the AP exam. So if you have one, you check one out for me, you're going to be responsible for bringing it to the AP exam. If you don't check one out from me, then you can know that I'll provide one for you on the day of the exam. Okay? So understand, you still don't have to buy one. You can either check one out and use that all the way till the end, or I will lend one to you on the day of the exam. Any questions about that? How many, just by getting an idea, how many are thinking about checking one out? Okay, a good amount of you. All right. Sabine, you want an extra one? You want to have one like in your car, and then one like in your backpack, and then one on your desk at home. Oh, okay. I was just teasing. All right. We're supposed to have a homework check today. It's not going to happen because it's just not going to happen. It's not. It's okay. It'll be another day. I don't know when. Might not even be tomorrow, because tomorrow we're having our trig quiz. Okay? Tomorrow is our trig quiz. I'm going to do one with you right now. And I put some blanks, some extras of these on the cart. If you want to take one, you can. It's this same one, though. This is not the one you'll be getting tomorrow, but it'll look just like this. So I'm going to go through this with you right now and explain to you how you can do this in 3 minutes, hopefully less than 3 minutes, using all the tricks I've told you. All right? So here's the thing. Knowing the unit circle, of course, is important, because the whole reason we know this is because of this. You need to be able to pull the exact values off of the unit circle in a timely manner, okay? You don't have to be able to do this timed perfectly in 3 minutes or 4 minutes or whatever it is. It's the reason I had you do that is because of this real step that's coming up. So trig functions are sine, cosine, and tangent. The exact values is what you get from the ordered pair. Okay? So I'm going to show you how you can do this very efficiently if you know this. And it's nothing new. It's the way I always do these, but it's been like a week since we've really done anything with it. So I want to remind you of some things that I'm noticing, and as I get back in the unit circle, my flashbacks of grading I know where students mess up. So your trig quiz, 10 questions, will be all unit circle. So no negatives, no coterminal where you have to subtract or add 2 pi. They're all on the unit circle. I will also make all of them radians except for 2, which will be in quadrant 1 degrees only. Okay? So I don't think I need to go over the degrees in quadrant 1. It's the radians where we start, not that we don't remember the ordered pairs. That seems to be okay. It's the signs. Okay? So let's review that. Quadrant 1, I don't think anybody ever messes up. That's the only quadrant where pi is by itself on top. Okay? Quadrant 2, all the numerators are 1 less. These are called proper fractions. Proper. All of them on the top half of the unit circle are proper. A proper fraction simply means the top number is smaller than the bottom number. That's all that means. And that should make sense. Proper fractions are all less than 1. Okay? That should make sense. These are all less than pi. Forget about the word pi. Just look at the number in front. All the numbers are less than 1. Okay? Once you pass that, we have all improper fractions. These are all improper fractions, which simply means the top number is bigger than the bottom number. Improper. Did I say improper? Improper fractions, okay? So these are all greater than 1. That should make sense. They go past 1, so they're bigger than 1. So if the top number is bigger than the bottom number, you know you're quadrant 3 or quadrant 4. If the top number is smaller than the bottom number, you know you're quadrant 1 and then quadrant 2. Now, we already know how to tell 1 and 2 apart. 3 and 4, the difference is 1. So if you subtract 1 from each of your numerators, you get your denominator. And in this quadrant, there's a difference of more than 1. It could be 2, could be 3. Who cares? Who cares what it is? It's just more than 1. Don't overthink it, okay? Because what I saw from you guys on the unit circle is we are getting the ordered pairs really well, okay? All of your denominators of 6 start with the square root of 3 over 2. All of your denominators of 3 start with 1/2. You know your middle ones are square root of 2 over 2. And then we have our quadrantals. So here's how we do this. Also, a review of tan. All of your denominators of 6, all of your denominators of 3, all of your denominators of 4 have the same tan value. What changes, though? The signs, right? And we'll talk about the signs, too. So all of my denominators of 4, what is your tan value? Quick. 1. Memorize it. It's easy. All of my denominators of 3 have a tan value of, well, square root of 3, right? But you're right. That's the 3 you're remembering. Good.
And then,
right. Then it's square root of 3 over 3. Those are all your tan values except for the quadrantals. That's it. Those are your choices if you have a denominator of 6, 3, or 4. And there's 4 of those on the unit circle, 4 of those, and 4 of those. This memorization covers 12 different trig functions. Okay? Exact values. 12 different exact values. Okay? Let's talk about the signs. And then I'll go through this with you kind of quickly. All students take calculus. This is one of 2 methods. So let's go over the original method I taught you, which is knowing that this is quadrant 1, quadrant 2, 3, 4. Everybody's positive in quadrant 1, right? Because we go to the right is positive, up is positive. So cosine is positive, sine is positive. In quadrant 2, how do we get to LVs? We go to the left is negative, up is positive. So cosine is negative, sine is positive. Quadrant 3, left and down, negative, negative. Right and down, positive, negative. Okay? So you've seen me. I told you that's what I do. I'm more of a quadrant girl. That's my method. That works faster for me. It's just quick. You would see me kind of doing this in the air during a quiz. Okay? I'm doing this. Okay, the other way, perfectly fine, and this is going to be really valuable. We use this all the time. Remember, this is where everybody is positive. Okay? Everybody, if you are the letter in that quadrant, you are positive. By default, if you're not a letter in that quadrant, you are negative. So A means what? All. Sine, cosine, tangent, all are positive in quadrant 1. We know that, right? Nobody really messes that up. In quadrant 2, sine is positive. So by default, tan and cosine are negative. It's a quick, you can glance at it. Tan is positive, so the other 2 are negative. Cosine is positive, so the other 2 are negative. Okay? So let me show you how we do this. So when I get a tan value, I don't need the ordered pair. I got this in my book. I see a tan, I see a 6, I go square root of 3 over 3. Immediately, I know it. Then I say, okay, improper fraction, chaos, quadrant 4. Positive and a negative means 2 different signs. One is positive, one is negative. Our answer is negative. For a quick glance at your all students take calculus, in quadrant 4, tan is negative because I don't see the letter there. It's an easy way, quick. Tan is negative, make it a negative. Make sure I can see the negative, okay? Again, tan is 0. I need ordered pairs, and I recommend you use the ordered pair for all of your quadrantals. So the right one, up 0, right? We get the 1s and 0s confused a lot, although you guys didn't on the timed quiz, so I was impressed by that. And tan is y over x. Don't leave it like that. Simplify it. 0 on top is fine. No calculators on this quiz. 0 on top is fine. So for the quadrantals, I don't mess around. I write the ordered pair every time. Okay? Next one, denominator of 6. Either think of the ordered pair or write it down. All of my denominators of 6 start with square root of 3 over 2. I'm in quadrant what? Quick. 4. Quadrant 4. I want sine. In quadrant 4, sine is what? Quick. Negative. So it's negative 1/2. If it's got a denominator of 2, it's one of my quadrantals. Top or bottom. Since it's bigger, it's on the bottom. Left to right, 0, down 1. I want cosine, answer 0. I see a tan with a 4, it's 1. You get partial credit just for getting that part. But let's get the sign right, too. We're in quadrant what? Quick. 2. Come on, Dylan, you guys study that. It's improper fraction. We're not quite 1. This is quadrant 2. Tan is negative. Another tan. Denominator of 3, square root of 3. Right? What quadrant are we in? 1. Everybody's positive. Moving on. Denominator of 4, square root of 2 over 2, square root of 2 over 2. What quadrant? Quick. 2. That means sign is positive. And that's what I want. Sign is the y value, square root of 2 over 2. I'll answer your questions in a second. Same ordered pair. Maybe you don't want to write it again. I need sign. It's quadrant 1. Same as that one. Square root of 2 over 2. You could very easily have multiple answers that are the same. Don't think I'm trying to trick you, okay? I hit a button that randomly changes them, so I just take those. Pi over 6. Denominator of 6, that's square root of 3 over 2, 1/2. Sign is this. We're in quadrant 1, 1/2. Cosine, 11 pi over 6. Okay, again, another denominator of 6. Square root of 3 over 2, 1/2. I need cosine. What quadrant am I in? 4. Chaos, right? The difference is more than 1. So you know it's quadrant 4. And cosine is positive in quadrant 1. Okay? Do we think we can do well on this? It's not bad. You guys did very well on the unit circle quiz. They're on the card, and I can print more. Dylan, you can get it later, okay? Yes, and I'll print more because my last period grabbed them up, okay? So just remind me after the notes to print some more, and I will be happy to print some more, okay? All right. So getting our notes out. Ready to go? Pretty short notes. Do I have physics people in here? Anybody are you currently in physics? Anybody already finished physics, like took it last year or something? Okay, so you were a physics person. Okay, good. It's good and bad when I have a physics person in my class. It's good because I can talk to them about some of the questions, like if I have a question about the physics part of it, but it's bad because I can't make stuff up, because William will, maybe Justin will call me out. I don't make stuff up, I'm just kidding. Okay, so what we're going to, really the only new part of today is this thing called frequency, and frequency comes up in word problems, so I will explain what frequency means a little bit better when we do the word problem that involves it. But period, we already know, is 2 pi over b. That's when we're working with an equation. We pull out the b out of the equation, we plug it in here, and then that tells us how much of the x-axis we are going to use, right? The period is the length of one full cycle of the periodic curve. So we know period is that. In a word problem, it's also time over cycle, okay? That is a formula we need to know. You're going to hear the word cycle in these word problems, and it's going to remind you, oh, that's got to do with the period, okay? So it's how much time it takes to complete one cycle of whatever the word problem is talking about. So we'll see that in a second. Frequency is the number of complete cycles the periodic curve completes in a unit interval. What that is, guys, is just the reciprocal of that. It's cycle over time, but instead of actually ever having to find that, you always end up finding period first, and then you can just flip this. And I'll explain what I mean in the word problem. So they are just reciprocals, okay? Reciprocals of each other means you flip one to get the other. Flip a fraction or flip something. They're reciprocals of each other. So we always start with period, and then if we need frequency, we're like, oh, we just take whatever we got for period and we flip it. All right? Before we get to our word problem, just a little review, less example on what I just said. So find the period and the frequency given just a regular equation. So like I said, we always start with period. We know how to find the period. What goes on top? 2 pi. And we divide it. Divide it by what we have. In this case, it's b, which is 1/4 keep, change, flip. So our period is 8 pi. So what does that make our frequency? 1 over 8 pi. They are reciprocals of each other. You just take one and flip it. Same thing here. Period is 2 pi divided by b. Pi's cancel. 2 over 48 simplifies to 1 over 24. This one's hard. What's the frequency going to be? Yeah, I'm just kidding. It's not hard. 24 over 1. It's just 24. Okay? Easy. Word problem. I'm going to read the word problem once through, then I'm going to go back and pull out some information that's going to be important. Okay? So, a mass on a spring oscillates back and forth and completes one cycle in 0.25 seconds. Its maximum displacement is 6 centimeters. Write an equation that models this motion if the spring is released from the maximum height. Find the frequency of behavior. Okay, let's go back over it slowly. A mass on a spring oscillates back and forth and completes, remember I said you'd hear that word, one cycle in 0.25 seconds. Cycle in time. Its maximum displacement is 6 centimeters. That's a physicsy term. Okay, we'll come back to that. We're going to write an equation, that's one of the things we have to do, that models the motion if the spring is released from the maximum height. You may not realize that's important, but it's super important, and I'll explain that in a second. And we're also going to find the frequency. So we need the frequency and the equation. Those are the two things that are going to answer the question. Now, I already hinted at that cycle in time. That's what we just learned. Period is time over cycle. Time goes on top. The way I remember that is like x-axis, y-axis. Kind of dumb. It's just the way my brain thinks. Time is always the x-axis. X comes before y. I don't know. We graph x first. Time's on top. First thing we come to in a fraction. Whatever works for you. Okay? So time, so period equals time over cycle. And that's what it says. One cycle in 25.25 seconds, which is a fourth of a second per cycle. So I'm just going to put it in fraction form because we use fractions more than decimals. So from that, I can find my frequency, right? My frequency, which is one of the two things I had to answer, I need to remember that I can just flip my period and get the frequency. So you can think of it as 4 over 1. That is 4 cycles in 1 second. In 1 second, it's going to complete 4 cycles of this springy motion. But we would just write it as 4, okay? So that's one of the two answers, what we need. All right, let's keep going. Now we need to write an equation. So then you say, okay, what do I need to write an equation in slope-intercept form? I would need m and b. What do I need to write an equation of a trig function? A and b. Now, remember I said there's this physicsy term in here? Maximum displacement is 6 centimeters. The definition of maximum displacement, and I had to look it up. I mean, I get all different word problems. I don't know what they all mean. I have to kind of dissect them just like you would. But maximum displacement, I think we're going to see again, is maximum displacement from the mean position is amplitude. So the mean, if you look here, is 0 between here and here. Maximum displacement is 6. So this maximum displacement, what you need to know, is your amplitude. So this must be, even though it's a real world problem, this is where, some of the real world problems kind of break some of our rules. We don't go into the negatives, but you really could just take this and adjust it. So it could be like, I don't know how to explain it. Just know maximum displacement is your amplitude. Do you have a better way of saying that, William? Do you remember maximum displacement? Yes. Okay. That's exactly what I was trying to say. easy way, though, to kind of navigate, though, is from here on out, maximum displacement is your amplitude. It is your amplitude, okay? Now we need B. Okay, we have a formula for that, right? That formula is who's on top, 2 pi always, right? Whether we're trying to find period or B from an equation or information is always 2 pi on top. And we divide by what we have. If we have B and we're trying to find period, that's what goes in the denominator. If we have period and we're trying to find B, that's what goes in the denominator, right? So our period, we already found that, is 1/4. Heap change flip, and our B is 8 pi. Now we have our A and our B, and we're ready to write our equation. But what's going to go right there? We've got A, we've got B, right? There's my A, there's my B. How do I know if this is cosine or sine? Well, it's hidden in there. I underlined it. It says from the maximum height. Starting up. Which one, sine or cosine, starts up? Cosine. So remember, you got to know this. Sine is middle up, middle down, middle. So middle start is sine. Starting at the top, up, middle, down, middle, up is cosine. Okay? There's no word problem in your homework, but when we do the exam review, test review, we'll see some more like physicsy questions, and they're very similar. Okay? Last thing we have to do, and I'm only going to do one of these, and that is pull some characteristics of the graph off of the graph that's given. And it says to consider the first period only, okay? And then we're going to come up with all 4 of these things. I love it when they make us, it sounds like I'm being sarcastic, I'm not. I love it when they ask us to go back and find concavity, intervals of increasing and decreasing, POIs. It's bringing us back to what we learned first quarter. Here it is again. How do we use the notation? The more times that we interact with something, the easier it is to remember it. So the first thing we need to know is what is a period of this graph. Okay, Dylan, wake up. Come on, guys. Or I'm almost done. I'm going to do A, B, C, and D for just A, and then you are ready to work. Count 5 points, right? Middle, up, middle, down, middle. So all we are looking at is that much of the graph. We know it continues on and on in both directions, but we're only talking about that. This period is 2 pi over 3. That's how far out 5 points goes. Okay, so part A asks for us to find the 5 key points for one period. Well, we just dotted them. Now you're going to name them. So 0, 0, pi over 6, 3, and so on. Go ahead and do the points. Justin, come on, guys. Wake up. Justin, come on. Name all the points. Yes, please don't sleep while I'm teaching. You have to keep waking everybody up. It's not nice. Okay? Pi over 2, negative 3, and then, where am I can't see it. 2 pi over 3, 0. Is this sine or cosine? Sine. Middle up, middle down, middle. 3 x-intercepts, a max, and a min. Being able to name points off of the graph. That's it. Part B. Identify the concavity. Concave up and concave down. So I'm going to use a little shortcut notation. Concave up, concave down. So when we name concavity, guys, this is important. We only use the x-axis, and we only use parentheses. Okay? So you probably agree with me that we are concave up. Nope, we are concave up from here to here. So that would be, can't see, pi over 3 to what? 2 pi over 3. Notice the parentheses. Yes, that's important. Only using the x-axis. We're concave down from 0 to pi over 3. Now, are we going to be concave up and concave down throughout the graph? Yeah, it goes on forever. See, but we only want to do for one period. So we're following the directions, just those two. Okay? Part C, intervals. Remember, whenever you hear that word interval, you know it's x-axis only, where the function is increasing or decreasing. So if you're increasing, you're literally going up. You have a positive slope. If you're decreasing, you're going down, and you have a negative slope. So increasing, let's see where we're increasing. We're going up from here to here. We're going up from here to here. This, again, is x-axis only, and here we use brackets. So from 0 to pi over 6, we are increasing. And in that one interval, that one period, we are also increasing from pi over 2 to pi over 3. Looking at my x-axis, where are we going up? What part of the x-axis? Decreasing. Huge section decreasing, right? This whole thing is decreasing. Grab the x-axis values. So that would be pi over 4, 2, pi over 2. Is that a 6? Pi over 6? I can't see. Pi over 6 to pi over 2. So pretty simple, right? The only thing left is points of inflection. Points of inflection are points, so ordered pairs, where we change from concave up to concave down. What's wonderful about sine and cosine graphs, unlike any other graphs, it's kind of hard to tell sometimes, is it's always x-intercepts. Look at them. That is where we change our concavity. And so unless there's a transformation up or down, it's going to be your x-intercepts. Now listen to me. There's a fight amongst math professionals that says the only one that you can list is this one. So here's the thing. In math, points of inflection where you change concavity can only be in your period that you're looking at. Fine. So why wouldn't it be this one and this one? So people like me say we should include those because we know what happens for sure. It's a sure thing that what happens after this point, we know the concavity changes. Because doesn't the curve just keep on going? So in sine and cosine graphs, why can't I list those? I know they are points of concavity. There's no chance that something else happens after these than what we can predict, which is that graph, that wave continuum. In other graphs, that doesn't occur. You would say, basically, maybe only these two, because we don't know what happens over there. So you wouldn't necessarily include that one. So there's a whole fight about it. I'm going to go ahead and list all three. And as we get closer to the AP exam, hopefully I'll have an answer for you as far as what the CED, the exam will be. So some of our questions will get answered when we start doing practice tests and see what kind of questions they're giving us and how they're giving the answers, okay? But just know, typically you would only include ones that you for sure know what happens after them. So some people would say just the middle one, some would say all three, some would maybe only say these two because you can see what's happening. So there's some discussion on that, right? All right. Homework. C18, 1 through 10 all. So I'm going to do 1 with you and 5 with you. Oh my gosh, again with the amplitude and the period, how many times we have to do this stuff. So amplitude is 4, of course, with a flip. Period is 2 pi divided by b, but if there's no b, it's just 2 pi. Max point, min point, and POIs, use the graph to find those, okay? So let's graph first, and then it's so much easier to go back and answer those questions. So I have an amplitude of 4, so I'm going to be as high as 4 and as low as 4, wherever that is. And they didn't label my x-axis for me, so I'm going to have to do that. I like to count by even numbers. You pick what works for you. But we need 4 sections of the x-axis. 4 sections covers 5 points, because your first point is on the y-axis, right? X, y-axis, on the origin, right? So let's go ahead and graph it, and then we can label the x-axis and answer the rest of the questions. So this is a cosine graph. Cosine is up, middle, down, middle, up, unless there's a flip, right? And then it would be down, middle, up, middle, down. Try to make it curvy. When our period is 2 pi, our little tick marks are the quadrantals. So maybe I just label those. I know the other two are the top and bottom number, pi over 2 and 3 pi over 2. And then it's easy to name my maximum and my minimums just looking at the graph. My max would be pi, comma, 4, right? This one right here. And then I have 2 mins. One at 0, negative 4. One at 2 pi, negative 4. And remember, your points of inflection are x-intercepts, whether you're sine or cosine. Okay, so that point would be pi over 2, 0, and then 3 pi over 2, 0. Okay. And then so that's 1 through 4. Oh, I forgot to say. See how there's a theta there? Theta is just a variable. It's just a Greek variable. That's the same as x. Don't let that throw you off. They can put any letter they want there. Greek or English. Doesn't matter. It's a variable. That's the same as saying cosine x. That's theta. Okay? So 1 through 4. We just did number 1 together. And then 5 through 10, really easy, guys. I'm making one part of it optional, so please just look up. I'm almost done talking. It says to do the rule, include the rule, which is this part all in blue. That's optional. Okay, if you want to practice that, if you need to know how to do it, you can. Or you can just kind of simplify life a little bit. And all you're doing is stating what is happening to G when we add in the numbers. So parent function, what did we do to it? Just describing the transformations from f of x to g of x. Okay. So using proper math language. All right, I'm going to print some more of those quizzes and grab them out of the workroom. You guys work. I'll be back.